What have you always wanted to know about Boise State Public Radio? Join us for another round Wednesday, March 19th at Mad Swede Brew Hall in downtown Boise from 6 to 8 p.m. Learn more about our operations, news content, and our service mission. We welcome your questions and look forward to sharing more about what we do here at Boise State Public Radio. More details can be found on our website at boisestatepublicradio.org.
From the studios of Boise State Public Radio News, I'm Gemma Gaudette. This is Idaho Matters. Mercury is a toxic chemical that can have devastating effects when it gets into our environment, especially into our waterways. Figuring out where it's contaminating our lakes and rivers is the first step to getting it out of the water. For more than a decade now, scientists have been using baby dragonflies to measure mercury levels around the country, and they've been using citizen scientists, especially kids, to help. So here to tell us more about the project are USGS research ecologist and co-author of the study, Christopher Kataulik, along with co-author Colleen Flanagan-Pritz. She is a National Park Service ecologist, and co-author Colin Eaglesmith, also a research geologist with USGS. I want to welcome all of you to the show.
Thank you.
Thank you. Great to be here.
So what is the Dragonfly Mercury Project? I mean, how are you using baby dragonflies to study mercury levels in our water? And Christopher, maybe you can take that.
Yeah, so we use dragonfly larvae, that not the adult form, the larvae that live in freshwater ecosystems. And we, through a citizen science approach, monitor the mercury that is bioaccumulated in these dragonfly larvae across protected lands, primarily the national parks. And so what these concentrations of mercury in our dragonflies tell us is the relative bioaccumulation or contaminant risk of mercury in these ecosystems. And so what we see is that from one freshwater ecosystem to another, we have significant variability across the landscape in the concentrations of mercury that we're seeing in our dragonflies.
Colleen, how many citizen scientists have helped out with this project?
Great question. Yeah, we're close to 9,000 different individual citizen scientists that have engaged in the study since its inception about a decade ago.
And I mentioned you use kids as citizen scientists. Is a big part of that 9,000 kids?
You know, it depends on what part of the country and what citizen group is engaged at each park. It just depends on established or new relationships that may be formed. But in some instances, it's 100% youth that do engage. Roughly, it's probably more than half that help collect the samples.
So, Colin, talk to us about how you get the dragonfly larvae. Do these scientists scoop it up out of the water? How does all that work?
Yeah, it's relatively straightforward. So, we'll go to rivers, lakes, or wetlands, and we tend to have long-handled nets that have mesh in them. And dragonflies the larvae will either be on the bottom of the lakes or on vegetation in that area. And so we'll just kind of scoop the nets around and pull the samples out and sort through the material that's in the nets and pick out the larvae.
So at that point, Colin, what happens after that once they're out of the water?
Once they're out of the water, we'll take them and put them in trays to help identify them. And this is where it's really great when you have kids involved, because you get more than dragonflies. We get a lot of diversity of life that come out, and we can identify, they get to see the different types of insects that live in waterways. We'll separate out the dragonflies, identify them to family, measure them, and then set them aside in sample containers to be returned to the laboratory.
Christopher, why use baby dragonflies, these larvae, instead of just taking water samples?
Mm-hmm. Yeah, so mercury is a contaminant that bioaccumulates and biomagnifies in food chains. And so this is an important characteristic of mercury, because if we were to take a water sample, it's not totally indicative of the bioaccumulation of mercury in that ecosystem. And so dragonfly larvae are what we refer to as bioindicators or biosentinels. And so they're going to be a proxy for the bioaccumulation that's occurring in those ecosystems.
Christopher, where does the mercury come from? And why do we need to keep track of it in our water system?
Yeah, great question. So there's natural sources of mercury from volcanoes and from underlying mineralogy in systems. However, human activities have released mercury into the environment, primarily through the burning of fossil fuels, as well as industrial activities. And so in national parks, which are again protected places and are mainly devoid of sources from industry, the main point of entry of mercury into these systems is from atmospheric deposition. And so mercury can get into the atmosphere and then deposited across the landscape, and remote protected places are not exempt from receiving these mercury inputs.
So, Colleen, what is it about dragonflies that make them such good indicators of how much mercury is in the water?
Well, dragonflies are, again, so they are bioindicators, like Chris said, in that they serve as a surrogate or a proxy for risk in other wildlife, like fish and amphibians. Furthermore, they are relatively easy to collect in the water. So when you have youth, say, going out to sample, they are easy to procure, if you will. They are representative of specific sites. So unlike fish, for instance, or birds even, they don't migrate long distances along waterways or airways, pathways, or otherwise, in which case they represent the mercury in that very little water body, which might be a pond or even a little puddle.
And Colleen, you've done this all over the country, right? I mean, not just here in Idaho, using these baby dragonflies.
Yeah, you're right. And it's not just us, right? Like we are just a part of a much greater team. We have people who have sampled in all but one state, and now even we are expanding into Canada as well. So it's very exciting to be nationwide.
And Colin, this kind of research in particular, has been going on for more than 10 years. What have you and your team found out about mercury levels in this time?
Yeah, great question. One of the key things we found out was that mercury levels are really variable across the country and not necessarily related to the inputs of mercury that come into water bodies or watersheds, and instead, and this is the paper that Chris just wrote, there are water chemistry variables that sort of activate the mercury and make it more available. And so we've really identified that the different variables that activate or make that mercury more available differ across the country. And so Chris and the team has been able to develop a model that can predict mercury concentrations in dragonflies based on the characteristics of the watershed that they're sampled in.
Chris, you actually have an interactive map, right, where you can see some of the results of the study, I mean, including craters of the moon in East Idaho. So can you talk to us about how the map works?
The interactive mapper is going to show dragonfly mercury concentrations that have been observed across the Dragonfly Mercury Project network. And so these are reported as mean concentrations, and they're going to give you an impairment value at a given site. And that impairment value can be used based on the concentration of mercury in that dragonfly at that sampling location, what the potential mercury risk might be. Now, the mapper tool is separate from the modeling effort, or the model that we just developed to predict mercury risk at these unsampled locations. And that is going to effectively lead into another phase of this project, where we're going to use the model as an engine, and that engine is going to integrate into a dashboard where national parks and other park managers can go in and select a location on that map and use the model that we developed to come up with a metric of mercury risk at that sampling location. And so this is different from the mapper, in that the mapper is showing the survey data across the United States. But the model that we developed using that network of dragonflies, we can make predictions at locations where maybe it's difficult to access, where there's not a lot of mercury data available. And we can give a metric of mercury risk and sort of a range of risk where park managers can go in and further sample and further investigate if mercury might be an issue on their lands.
And before I let you go, do you still need people to help out with the study?
We always welcome new participants. So as more parks continue to engage, and likewise reach out to their communities for involvement. We ultimately would defer to those parks at a local level on how their operations run. But oftentimes we do have folks that are reaching out to us and asking if they can be involved. So if there is interest, dmp@mps.gov, and they can get connected to a park that may be sampling near them.
Well, I want to thank all of you so much for the conversation. Really interesting. We've been speaking about the Dragonfly Mercury project with USGS research ecologist Christopher Kutaulik and Colin Eagle Smith, along with National Park Service ecologist Colleen Flanagan Fritz. You've been listening to Idaho Matters from Boise State Public Radio. I'm Gemma Gaudet.